Yes. All right, guys. Are there any questions on the homework assignment from yesterday? Okay, if there's no questions on the homework assignment from yesterday, what we're going to be talking about today is simplifying rational expressions and multiplying rational expressions. So we're simplifying and multiplying rational expressions today. And any rational expression is a polynomial, is a fraction with a numerator denominator that have polynomial expressions or functions. So it'll have a variable in the top and bottom. And we're going to consider it simplified if there are no common factors. So there cannot be any common factors in the numerator or denominator. So this here, our core concept here, is really kind of giving it an example of this. Because for this here, AC divided by BC, well, the numerator and denominator both have a common factor of C, which we can simplify out, leaving us with A over B. The same thing is true for numbers, because 15 over 16, or 15 over 65, both of these, the top and bottom, have a greatest common factor of 5 that we can factor out, or divide out, leaving us with 3/13. We can do the exact same thing with polynomial expressions, because the numerator and denominator both have an x plus 3 in common on top and bottom. We would divide it out, leaving us with 4 over x plus 3. So anything that is in common on top and bottom that we can factor out, we're going to do so. Now, the first one we're going to look at here in simplifying this rational expression is this here, 4 over x times x plus 2. Is there anything in common on top and bottom? Anything uncommon on top and bottom? So we do see that there's a 2 here and a 2 here, but unfortunately, this x and 2 are connected with the x plus 2. X plus 2 is going to be one whole term. So we can't just simplify the 4 and 2, because it is not together. X plus 2 is together. It is one term. So we can't just simplify these two here. Well, the only way that we can simplify this 4 is if there's a 4 or a 2 being multiplied out front. Well, is there anything being multiplied out front that would be in common with the 4? No. There's not a 4 or 2 out here. Is there an x plus 2 on top and bottom? Is there an x on top and bottom? No. So this here is simplified. This is as simplified as it gets. Because there's nothing in common on top and bottom, we can't do anything to it. All right, let's look at this one here. Is there anything in common on top and bottom? X plus 1. So what we can do is we can actually think of this as x plus 1 over x plus 1 times 2 over x plus 3. Because when we multiply fractions, we multiply straight across. So watch this later so that you're ready for tomorrow. Okay. Now we can think of it like this here, because the x plus 1 times 2 on top split apart is still going to be 2 times x plus 1. The denominator is still the same as we had it before, as x plus 1 times x plus 3. But the reason I write it this way is to show the fact that, well, these two here, anything divided by itself is 1. Simplifies to 1, kind of cancels out. Which really just leaves us with what? 2 over x plus 3. And this is our answer. And we can do this with multiplication, this simplifying. But we can't do it if it's addition and subtraction. So even if this 3 had been a 4, the 2 and 3 don't go together. We can't simplify them because on bottom that x and 3 are connected with the addition. Addition and subtraction really lock them together. Just an extra mark. Any other questions on this here? Let's look at this next one here. Now, for us to be able to do anything with this, we're going to need to factor. We're going to have to factor the numerator and denominator to be able to work with this. So we'll have to factor the numerator and factor the denominator. Which one do we want to factor first? Doesn't matter because we're going to factor both. Which one does it look like it'll be easier to factor? The bottom, the x squared minus 4, because x squared minus 4 is a difference of perfect squares. So it would actually factor the b. Here, x minus 2. Now we do need to factor the numerator. When we look at the numerator, this trinomial, well, the third term is negative, so our signs are going to be opposite. One is going to be positive and one is going to be negative. Now we look at the factors of the first and third term. Well, the factors of the first term are x and x. That's the only factors of x squared. Now we need to look at the factors of 12. Well, we have 1 and 12, 2 and 6, and 3 and 4. Which one do we want to try first? 2 and 6. One of the big reasons I would pick 2 and 6 is because of what? 6 minus 2 is 4, exactly, yes? Yes, because 6 minus 2 is 4, or 2 minus 6 is negative 4. But we also want, because if we're wanting to simplify, we need something to be in common on top and bottom, yes? Well, what's on bottom? X plus 2 and x. So if I want something to simplify on top, I either need an x plus 2 or an x. And looking at all the factors, well, hey, 2 and 6, we do have a 2. That would give us a common factor on top and bottom, yes? Now, would the 2 be positive or negative? Positive. Because we are looking for common factors, and I would use that especially when we're factoring multiple things, because it does help us to figure out factors faster. Now, if we do check this here to make sure we got the right thing, x times negative 6 would be negative 6x. 2 times x is going to be plus 2x, which would give us a negative 4x, which is the middle term that we wanted. Any questions on this here? Now, do we have something in common on top and bottom? Yes. The x plus 2 and x plus 2, which will cancel, leaving us with what? X minus 6 over x minus 2. Do we have anything else in common on top and bottom? Well, 6 and 2 do have a greatest common factor of 2, yes? But are they by themselves? No. Because really these are locked together. That addition and subtraction locks those two together. So this is as simplified as it gets. All Any questions on any of this here? This is to check to make sure we factored this correctly. Any other questions? Okay. Let's look at this next one here. Back to the top. Back to the bottom. So looking at these two here, which one do we want to factor first? The bottom. X squared minus 9 would be what? X 3 and x minus 3. Because again, x squared minus 9 is a difference of perfect squares. So we'd have x plus 3 and x minus 3. Now we do need to factor the numerator, x squared minus x minus 12. Since the 12 is negative, our signs would be opposite, positive and negative, because if the third term is negative, our signs are opposite. If the third term is positive, the signs are the same and they match the sign of the middle term. Now the factors of x squared are x and x. Well, again, we're looking at the factors of 12, which are 1 and 12, 2 and 6, or 3 and 4. Well, we need one of these to have a 3, so we're looking at 3 and 4. And it does work out that 4 minus 3 is 1, or 3 minus 4 is negative 1. So we would need the 4 to be negative and the 3 to be positive. And again, we could check this if we wanted. 4x times negative 4 would be negative 4x. 3 times x would be plus 3x, which would give us a negative x, telling us we factored the numerator correctly. Now, what do we have in common on top and bottom? An x plus 3 and an x plus 3, which would cancel, leaving us with x minus 4 over x minus 3. Well, before we move on, there's one other thing I really should have mentioned on the first one. It's not going to really come up too much, I don't believe, for this here, but we can't have the denominator be what? There's a value it can't be for any denominator. What can we not have in the bottom of a fraction? 0. We can't divide by 0, right? So with any of these here, I cannot have a value of x that would make the denominator 0. But looking at x plus 3, what value of x is going to make x plus 3 0? Negative 3, because what is negative 3 plus 3? 0, so x cannot be negative 3. Well, x minus 3, it can't be 3, because if x is negative 3 or 3, the denominator would be 0, because 3 minus 3 is 0, and negative 3 plus 3 is 0. But that's not going to be too big of a deal until we start solving. But we'll still list them out. Let's look at this one here. So when we look at this here, x plus 4 is in the numerator. Can I factor that any farther? Well, no. It's just going to be x plus 4. Now, the denominator is factorable because it is a difference of perfect squares. And that would factor to what? X plus 4 and x minus 4. Do we have anything in common on top and bottom? The x plus 4. So x plus 4, this whole thing, because this is one whole term, would cancel out with the x plus 4. Now in the denominator, we'll be left with x minus 4. What is the numerator going to be? Because whenever something simplifies out completely, we're left with 1. So this here would be simplified completely. But if we wanted to look at the restrictions, we're really looking at what is going to make both of these here be what? 0, because it can't be 0. Because we could set them equal to 0 to solve to see what x plus 4 would be 0. Well, we would subtract 4, telling me x is equal to negative 4, so x cannot be negative 4. And what's going to make x minus 4 equal 0? We can add 4, and then tell us x is equal to 4. So for this here, x cannot be negative 4 or positive 4, because it would make the denominator equal 0. Because for any of these here, the denominator cannot be 0. We cannot divide by 0. Any questions on any of this here? I'm going to look back at it, and if it does ask for it, it'd be good to do, because it's a good thing to be in the habit of, because when we get into solving, this will save you a good bit of time. Because if one of our answers when we solve is one of these two numbers here, we know it's an extraneous solution. Because any extraneous solution is a solution we arrive at, but will not work in the original problem. Questions on this here? Okay. This here is the first one we have where the numerator and denominator is not a difference of perfect squares. But we can still factor it all the same. Which one do y'all want to factor first? The numerator or denominator? Which one do you think would be easier to factor? Denominator. So we looked at this one here, x squared minus x minus 6. Since the 6 is negative, our signs are opposite. Now we look at the factors of x squared, which would be x and x. And now the factors of 6 are 1 and 6 or 2 and 3. Which one do we want to try first? 2 and 3? Would the 3 be positive or negative? Negative. And if we did check this here, we would get negative 3x plus 2x is negative x. The middle term is negative x, so this is the correct factorization for this here. Any questions on the denominator before we move to the numerator? Okay. If we look at the numerator, x squared minus 2x minus 3, since the third term is negative, our signs are opposite. One's going to be positive and one's going to be negative. Now the factors of x squared are x and x. And well, the factors of 3 are 1 and 3. There's only one set. We would need the 3 to be negative, because if we're going to have a common factor on top and bottom, we need the x to be minus 3. Now if we do check this, this does work out, because x times negative 3 would be negative 3x. 1 times x would be plus x, which does give us a negative 2x middle term. And as I think as some of you have already done, we do see that there is an x minus 3 on top and bottom, which does cancel out, leaving us with x plus 1 over x plus 2. What would the restrictions be here? X cannot equal what? -2 or +3. Because the x plus 2, because -2 plus 2 would be 0. And x minus 3, well, 3 is going to make that 0 because 3 minus 3 is 0. Any other questions on this here? Multiplying rational expressions. Whenever we multiply rational expressions, we multiply straight across. And that works with any sets of terms. We're going to multiply straight across here. Now, when we simplify, we can either simplify after we multiply together or at the very end. And we'll look at different ways that we can do this. So this here, we're going to find the product of these two here. And whenever we multiply two rational expressions, we multiply straight across. So looking at this here, well, we have 8x to the third y on top, and we also have 7x to the fourth y to the third. So the first thing we can do is we're going to actually be multiplying the numbers together. So we're going to be multiplying 8 and 7. Then we would be multiplying x to the third times x to the fourth, because they are like bases. And then we would also be multiplying y and y to the third. And at this point here, I'm just rearranging them so we have the like terms that will be multiplied together next to each other. On bottom, we would have our 2 times 4, because those would be multiplied together, our numerators. Well, we only have one x out of all of it. And then we'd be multiplying our y and y squared together. Now, one way we can do this when it's just these monomial one terms on top and bottom of both rational expressions, we can multiply everything together and then simplify at the end. So the first thing we can look at is 8 times 7, which is 56. X to the third times x to the fourth, x to the 7, because when we have like bases being multiplied together, we add the exponents, which means the same thing is true for y times y to the third, be y to the fourth, and that's everything on top. On bottom, we have 2 times 4, which would be 8x, because that's the only x that we have. And y times y squared would be y to the third. Now, we do need to simplify anything that is a like term on top and bottom. So the first thing we can look at is 56 over 8. Well, does 56 divide by 8 evenly? It's 7, so okay. Bigger on top, I'm going to put it on top, because it'd be 7 over 1 or just 7. Now we're looking at x to the 7th over x. Whenever we have like bases being divided, we subtract the exponents. And the exponent on bottom would be 1. So 7 minus 1 is 6. And is it bigger on top or bottom? Top. So it stays on top. And lastly, we have y to the fourth divided by y cubed. So 4 minus 3 is 1. And it's bigger on top, so it stays on top. So the actual answer is 7x to the 6 y. And that's it. I will always put the division sign just in case we do still have something on top and bottom. If not, I kind of just include it in the circle. Any other questions on this here? So, again, we can look at this here and rearrange it so that the numbers are next to each other, or the terms are next to each other that will be multiplied together. So we are going to be doing 6 times 9. We also have x squared times our x to the 5th, because those are like terms. And then we would have our y times y squared. On bottom, we'll have our 3 times 2. Well, again, we just have nx. And then we have y to the 3rd times y. Really, all of these are being multiplied together on top, and all of these are multiplied together on bottom. Now, really, if we wanted to here, you don't have to write this down because I'm going to end up erasing it. We could, if we wanted to, go on and start simplifying here. Because what is 3 times 2 on bottom? 6. So realistically, this and this here would cancel out. Well, one of these x's here would cancel out with one of those there, really just making it x to the 1st. How many y's do I have on top? 3, yes? So these 3 really would cancel with those 3 there, leaving me with 9 x to the 6 over y. Because we could simplify there. We don't have to. Because we can still stick with 9 times 6 is 54. X squared times x to the 5th would be x to the 7th. Y times y squared is y to the 3rd. 2 times 3 is 6. We'd still have our x, but then we would have y to the 4th. Now, 54 over 6 would reduce to 9 over 1. Now, x to the 7th over x, well, 7 minus 1 is 6, and it's bigger on top, so it stays on top. Now, with y's, we have y to the 3rd over y to the 4th. It would be on bottom, because we can do 4 minus 3, and 4 minus 3 is 1, and it's bigger on bottom. We just have y to the 1st or y on bottom. Because if we followed this mathematically, it would be 3 minus 4, and 3 minus 4 is what? Negative 1. So we would rewrite it as y to the negative 1 on top, but we can't have a negative exponent, so we have to move it from the numerator to the denominator to make it positive. Or I can just subtract the exponents and say, where is it bigger, on top or bottom? Because if it's bigger on bottom, it stays on bottom. If it's bigger on top, it's going to stay on top. And this is our expression here. Any questions on any of this here? All right. There's one other way that we can look at this. Don't write this one out because it's not as effective, but I still want to be able to show this to y'all. And that's rewriting these as prime factorizations, writing them as multiplication of all prime numbers, or as small as we can get it. Now for 3, well, that's as small as it gets. X to the 5th is just telling me that I have x times itself how many times? 5 times, yes? So what we could do is I could actually rewrite it as 1, 2, 3, 4, 5. Y squared would be y and y. Now the prime factorization of 6 is actually 2 times 3. We only have one x, and then we have y twice. And that would be the prime factorization of the numerator. For the denominator, well, the prime factorization of 8 is 2 times 2 times 2. Well, then we would have xy. And for 9, it is 3 times 3. X cubed would be x times x times x. and then we have y. What I can do is put them all together. So 2 times 3 times 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. And on bottom we'd have 1, 2, 3, 3, 3, 2, 3, 4 x's and 2 y's. And well, now I can come back and cancel out what's in common. So one of these 2's would cancel out with one of these. These 2 3's would cancel out with these 2 3's here. These 4 x's and these 4 x's here would simplify. And these 2 y's would simplify out with these 2 here. There should be, thank you. Yep. So that really should leave us with x squared, y squared over 4. This is not the most effective way to do this. Most likely, I think the way that y'all would do it and the way that I would do it a little bit is that we can look at this here. On top, we do have 3 times 6, which is what? 3 times 6 is? Guys, wake up. Kim, thank you. 18. Guys, heads up. 20. Thank you. Now we can multiply the variables together. X to the 5th times x would be x to the 6th. Y squared times y squared would be y to the 4th. On bottom, we can do 9 times 8, which is 72. X times x cubed would be x to the 4th, and y times y be y squared. Now at this point here, we can do 18 over 72 in a calculator. It will simplify it, and it'll simplify it down to 4. And now for our x to the 6th over x to the 4th, 6 minus 4 is x squared, and it's going to stay on top since it's bigger on top. And y to the 4th over y squared is going to be squared on top. And we get this here. And we can simplify in any of those different ways. Any questions on any of this here? All right. Now we can do the exact same thing with expressions where we have more than one term. Now before we do any of the multiplications, we will need to factor them, because we'll want to factor each one of these expressions here, so it's easier to multiply and easier to simplify at the end. Now looking at all these all 4 of these, well, the 3x is as simplified as it gets. There's no other terms with it. We can't simplify it any further. Now let's look at the other ones. Well, I think the next easiest one to factor would be our 3x minus 3x squared, because there is a greatest common factor between those 2 terms, which is what? 3x, and we can factor it out. And if we factor a 3x out of 3x, we are left with 1 minus what? X. Because the 3 out of 3x squared would factor out completely. And if we remove 1x from x squared, we're left with x. Now that does leave the other 2. Which one of these do we want to factor first? Well, okay, we'll go on with the denominator of the first. X squared plus 4x minus 5. Since the 5 is negative, it means our signs are opposite. One is going to be positive and one is going to be negative. Now the factors of x squared would be x and x, because that's the only set of factors. And well, the only set of factors for 5 are 1 and 5. The 5 would be positive and the 1 would be negative. And we could go back and check it and see that this does give us a middle term of 4x. So these are the correct factors. Now let's look at the other one, x squared plus x minus 20. Since the 20 is negative, our signs are opposite. One's going to be positive and one's going to be negative. Now the factors of x squared would give us x and x. Now the factors of 20 are a little bit more than 5, because we do have 1 and 20, 2 and 10, or 4 and 5. Which one would be helpful to use? 4 and 5. And we would need the 5 to be positive. And if we did check this, this would give us a positive x for our middle term. Any questions on this here before we multiply them together? Now, when we multiply these together, we're going straight across. In any greatest common factor terms like 3x, I would move to the very front. We'd have 3x times 1 minus x times x plus 5 times x minus 4 over 3x times x plus 5 and x minus 1. Do we have any like terms on top and bottom? So the 3x and 3x, yes. X plus 5 and x plus 5, yes. Anything else? I think I heard someone mention the x minus 1. And the other one's just flipped, yes? Because the x is negative and the 1 is positive on top, where on the bottom the x is positive and the 1 is negative, yes? Well, we can't just cross them out yet because they aren't the exact same. But I do want to rewrite it because it is possible for these to simplify. Because what we can factor out of this is a negative 1. Because if I factor a negative 1 out, I factor the negative out, the x, which here is negative, is going to become what? Positive. And the 1 here, which was positive, is going to become negative. Well, now are they the same? So yes, so these would cancel, leaving us with negative x minus 4. So really on a problem like that there where we have the squared, because 3x squared was negative, we could have factored that negative out to begin with and not had to worry about it at the end. Any questions on any of this here? Now, the denominators will not be 0. We can't have 0, which would really be looking back at this here before we'd simplified. And it would have really just told us that x cannot be 0, 1, or negative 5 if we were looking for those there. Now, that's all we're going to do for today. We will finish this to